square roots of variable expressions, that we are still working with these square roots. And so the number part of it, we've already done. And all we're going to be doing today is adding in some variables. Okay, so for example, the square root of 196y squared. Now, before we do that, we'll get to the 196 part in just a minute. For today's lesson, most of these answers are going to be perfect squares. Okay, so I'm trying to check the homework just to double check. If they're not perfect squares, they should simplify down where you don't have anything left under the radical for the most part. So rational square roots. Now, real quickly before we solve this one, let me just come over here and let's just do a quick reminder of something squared. If I said, and you don't have to write this part down, if I said 3 squared, right, we'd get 9. So just to review with the plain numbers, if I say the square root of 9, it's just that base, right? So that stuff we've been working on, that's not a problem. If I had x squared, right, something times itself, what if I took the square root of x squared? Think about this. If this has been squared, it would be like the 9, right? The 9 has been squared. And so when I take the square root of 9, look at what I get. I get the base without the exponent. So if I take the square root of x squared, what you're going to get is that base. So this part you might want to write down. You know how we've been doing inverse operations? Addition and subtraction are opposites, multiplication and division are opposites. Well, it turns out that really this is another inverse operation. The radical sign and the square, now this is only for the power of 2, these cancel each other out. So if you have a power of 2, then it should be relatively simple. The square root and the power of 2 undo each other. They cancel each other out. They are actually inverse operations. And so all that's left is that base. Okay, now that's only if it's the power of 2, but I'll show you what to do if you have a different exponent when we get to the next problem. Now, square root of 196. One thing to try on here is, first of all, use your calculator and see if it's a perfect square. Oh, what do you know? 196 is the perfect square of 14 times 14. I don't expect you to have that one memorized. However, if you didn't get a whole number here, then you would need to use the method of does it have factors that are perfect squares and to break it down. Okay, but we could check it here. The square root of 196 is 14. What's going to be the square root of y squared? Brian? Y. So that's if it's a power of 2. Let's look at one that's not a power of 2, and I'll show you another way to think about it. 36, let's say x to the power of 8. So the first part's simple, hopefully. Square root of 36 is 6. Now, x to the power of 8. Think about this. If I want to take the square root, this radical sign, always means squared, something times itself twice. So what I need to figure out is what times itself would have equaled x to the 8th. And let me remind you here of one of our exponent rules. When we multiply the same base, because these are going to have to be x's, right? When I multiply the same base, I add the exponents. Well, technically, if we were just adding exponents, we could have 1 and 7. That makes 8. We could have 2 and 6. That makes 8. But in this situation, it has to be the same thing times itself. So what's the only option? If they need to add up to 8, but they have to be the same number. Pammy? 4, right? So if you have any exponent bigger than 2, on that first one, the square root and the power of 2 just cancel each other out and we're left with y. Here, we just have to think about, well, what times itself would have equaled x to the 8? The answer, as you can see, is x to the power of 4. So the square root of x to the 8 is x to the power of 4. okay? And so that's really what we're doing here. I'm just going to show you a couple more examples. Oh, actually, let me take it back. We're going to get a little fancier. Those are the simpler versions, but you know, just be careful with the exponents. That's really the new part. Now, I think you guys have hoped these would go away, but here comes our friend, the trinomial. It's back. It's back. Now, if you see a trinomial and we have to factor it, back to chapter 5. Now, here's the good news, guys. You're only going to see something like this. We want it to be a perfect square. We want this to cancel out like it did with the y squared up there at the top, right, or right here. If we could have something that was to the power of 2, then the square root and the power of 2, the exponent would cancel out. So let me just remind you of a pattern that we had. And I know you're hoping this is going to go away, but it's not. We're going to see it again later on, I think in chapter 12. And of course, you'll see it when we review for the final. So this is like a little mini review. We had this special pattern. When you had this pattern, now this was the one where it has the minus here, so I'm just matching that, and the last one's always a plus, that if you had this pattern, that comes from the square of a binomial, meaning a binomial times itself, perfect square. Okay, this was maybe 5.5 or 5.6, I don't remember exactly which lesson. The only other option here was, and you don't have to write this one down for this problem, but just to remind you, was where they were all pluses, and that just meant that there was a plus inside the binomial. Now I'll tell you, normally when we did this, I would say, oh, let's find the A, let's find the B, and now let's check it. That's kind of what you want to do here. But first, let's keep our square root sign, because the first thing we're going to do is see, can this be factored down to this? Because then if it can, this is what we're hoping it'll do, then the square root and the radical will go away. So if m squared is my a squared, what would the plane A be? What times what made m squared? M, right? That part you should. And because there was a minus, we keep the minus. What times what made 9? That, of course, would be 3. Now, remember the double check we always did for this middle piece. 2ab, we'd go, oh, 2 times my a, which is m, times 3, which is my b. That should be 6m. Was it 6m? Yes, it was. Okay. You have to check those patterns real quickly, but it shouldn't take too long, right? Square root of m squared is m. Square root of 9, 3. But it's in the binomial. So now, if the square root and the exponent cancel each other out, what is going to be left for my answer? The square root and the power of 2 undo each other and cancel each other out. What's left? Diego? With or without parentheses? There's your answer. I know, it's fun. I know you guys missed factoring. You missed your friend the trinomial. It's back. Last example. I'm sorry, second to last example, but they're quick, I promise. That's the only one for factoring. Now, what if they're not perfect squares? I said that most of them are, but they might not all be. So we're going to do this pieces separately. The 18 separate from the a cubed. Square root of 18, again, we want to look for factors that are perfect squares. 18 has 9 times 2. The square root of 9 is 3. The square root of 2, I don't know, so I leave it under the radical. Now, a cubed, if you have an odd number, you can't take the square root of that, and we're not going to get a decimal as an exponent. So what we need to do is figure out what's the biggest even number I can pull out of here. I could do an a squared times a, right? That's the same as a cubed, a squared times a. And now, so it's kind of like this, where we separate out the piece we can pull out of the radical. I can do the square root of a squared. The square root of a squared, well, the radical and the power of 2 cancel out, leaving just an a. The square root of plain little a, I don't know. It's like the 2. I don't know. So I just leave it. Okay, so again, if you have an odd number, take the biggest even number out, because that you'll be able to take the square root of. That one that's left over stays under the radical. Now, the way this looks is not ideal. let's put everything that's outside the radical together. The 3 and the a, it's all being multiplied. So we can just commutative property, move it around. 3 times a, let's put that together. Everything that's under the radical sign can stay. So 2 and a, 2 and a, reunited. And that's it for that one. So just doing the separate pieces and factoring out or simplifying out what you can. Last example, this time for real. Last one. Now, slightly different. Solve. Which means we're going to have an equal sign, and you're going to be able to get an answer for x. The only difference here is we've got the x squared. In the past when we did this, our variable usually didn't have an exponent. So just remember that if we're trying to get the variable by itself, if I want to find x, I'm first going to leave the x alone and I'm going to undo the other stuff. The other stuff here is times 9. So I'm going to do the opposite. I'm going to divide both sides by 9. Now, I still have x squared. I don't want to know x squared. I want to know x. How can I get the power of 2 to undo? I've been saying it this lesson. How do we undo it? Luke? Yeah, if I take the square root will undo the power of 2. Now, if I do it on the left side of the equation, guess what? I have to do it on the right side as well. Whatever we do on one side, we have to do on the other. So square root of x squared. Hey, these cancel each other out, leaving just the x. And now all we have to do is simplify this. When it's a fraction, take the square root of the top part, square root of 64, 8. Take the square root of the bottom part, square root of 9, 3. Done. You can leave it as an improper fraction. That's it.